So hopefully that'll come up in a second. So how are you guys doing? Okay. So just remind me again, how many of you have prior Java programming experience? Okay, good number. So that's good and bad. It means that the assignments are boring for you guys and impossible for people who haven't programmed in Java before. So not a great situation to be in. So we'll do a little bit more Java today, and then after that, I don't think we're going to do too much more about Java per se, although it will be the language that you use for the final assignment. But before I talk about that, how many of you have received this invitation to do the teaching evaluations? So that comes probably to your Carleton email account. So there's a couple of things I would like to say about that, because it's come to my experience from past years that students don't really know what happens to these things. In fact, you get students going through 4 years of these things, diligently filling out these evaluations for every course, every semester, and then really wondering what happens to this information. So, has anybody filled theirs out yet? Okay. So you'll know that there's two parts. There's a first part, which is a bunch of numerical scores. So I think there's 13 questions. They ask you about different aspects of the course and my offering of the course, and you pick a number that can be between 0 and 5. So these numbers, they are kept and used for basically career advancement stuff. So I want you to answer these honestly. Don't try and be nice and be nice to me. Don't worry about hurting my feelings. It's better if I know that I'm doing badly at something, because, well, for one thing, the career advancement aspect is no longer really relevant to me. I have tenure already, and I'm already at a rank that basically the next step after this is that I die. So don't worry about that. And I don't think that no matter what scores you give me, that's not going to bring me closer to being dead any faster or any slower. So be honest there. But the other part is a free form. It's basically free form text. And here, this is the stuff that I actually do care about. Here, I would like you to give me your impressions about the course. And one thing to note is that I am the only person who will read these things. So I know that students don't normally know this, because even in 4th year, they write things like, oh, this guy is really annoying, he has a funny voice, and his hair is usually messy. When really what they should be writing is, you are really annoying, your hair is really messy, and you have a funny voice. Because it's really, I'm the only person who reads them. So these are directed straight to me. And what I would like you to write about there is stuff that you liked and stuff that you didn't like about the course. So in particular, the style of lectures. Would you prefer if I do as I've been doing, sitting down and programming in front of you, or would you prefer if I had a slide deck of pre-made slides that show all the code already written and whatever else? You can express your annoyance about the lag in the audio on the videos. That's fine. I'll probably have a better computer next year, but that doesn't help you guys. So sorry. As well, you can tell me what you think of the different kinds of assignments. So, did you like the assignments in which you tried to solve some algorithmic problems where there was some focus on efficiency? Did you like the assignments in particular with with Pygame? Was that something that was interesting to you, or just painful and boring? It's all good information for me to have, because well, I'd like to make this course as interesting as possible. I know it's too late for you guys, but you can help me the next time I teach it. And so that's what that part is for, and this is really for my eyes only. And then there's a third aspect, which is not has nothing to do with these formal teaching evaluations, and that's Rate My Professor. Have any of you heard of this website? Yeah. So it's a place where you go, .com, and there's a .ca version as well. You go and write comments about a professor and a particular course that they've offered, and those are made publicly available for everyone to look at. And the reason that I recommend this is, well, these other two things, one gets kept in a file somewhere and will probably never be looked at. The other one will be looked at by me, but none of that helps anybody else who's going to get me as a professor later, or who has an option to either choose me or choose someone else. So really, if you want to leave advice for future generations, or this generation next year of programmers or computer science students, this is the place to do it. And I have a thick skin, so put whatever you want there as well. Okay, so I want to save this as, let's call it today.java. So this has nothing to do with today's lecture, but we'll leave it in the comments anyway. All right, so I want to write, I want to play around with Java a bit more. So here I've created this file called today.java. So if I want to do anything in Java, what's the first thing that I have to do? Yep.
Create a class.
Got to create a class. Everything in Java has to live inside some class. And what should the name of this class be? Same as the file name. So the file is called today.java, so the class should be called today. Okay. Now I've created a class. If I want that class to be able to run, what do I need to include? A main method. Does anybody want to be completely precise?
Public static void main string.
Yeah. Okay, so here's a quiz for you. So that's the main method. Is there anything on that line that I could change and it would still run? Yep. Yeah. I can put anything I want here. But everything else on that line has to be exactly like this. So it has to be a public method, which means that it's accessible from anywhere. Anybody is allowed to run this method. It has to be a static method, which means that it doesn't need an object to run on. It's just a standalone method, what we call in Python a function that just runs by itself. It should have a return type of void, which means it doesn't return anything. Its name has to be main, and it has to take one argument, which is an array of strings. And those are the arguments that are passed on the command line to it. Okay. So the only place you have any flexibility here is in this, the name of this thing. And I should mention the naming conventions in Java are different from those in Python. Class names are like in Python. You use a camel case with a capital first letter. So, if this had a more complicated name like today's class, it would be something like this. So you use a capital letter for for each word, the beginning of each word. Method names are usually in camel case, starting with a lowercase letter. So, for example, you often have methods that are things like get first, stuff like that. So every word is capitalized except for the first one. And same thing with variable names. So usually not so many underscores get used in Java. So the right way to write this would be my favorite name. Nothing enforces that, but it's the usual conventions for Java programming. All right. So we remember from last class or last year or your last 5 years of programming in Java, depending on your experience level, that anytime you want to have a variable, you need to give it a type. So let's define a variable called n. That's an integer, and we'll assign it the value 10. And basically, this notion of specifying the type of a variable carries over to everything. So for instance, it carries over to arrays. So if I want to create an array, it's not just enough for me to say I need an array. I have to tell you exactly what kind of thing goes in the array. So for example, this is an array of strings. And let's say first string, second string, third string. So that gives you an array of strings, and we saw that there's these for loops, where basically two kinds. So I can do the for loops like the standard ones in Python, where we specify a variable and say we want it to take on all the values inside an array. So some string s, I would like it to take on each value in A, and then I could print it, for example. So that will go through the elements of A one at a time and print them. Or I could use a 3-part for loop, which looks like this. So here I declare a variable I, which starts out being equal to 0. Then as long as I is less than a.length, we'll execute this block of code. And once that block of code is done executing, we'll increase the value of I by 1. So this is like the standard template for a for loop that iterates over the elements of an array or a list or any of these things. So if I run this, or before I run it, I have to compile it. This is called today.java. So the most likely thing that could happens is that you get a syntax error. And what's the syntax error? Yeah, missing semicolon. It's a real danger of mixing programming languages when you're programming both in Java and in Python. Forgotten semicolons happen all the time. Cannot find symbol S. That's because there is no S. This should be A at I. Is it going to have the same what?
You have two for loops printing out that thing, so you just change one of them to be A and I and the other one. So.
Yeah, so this for loop actually declares the string S that iterates over the elements of A, so that it takes on the values of A, of the elements in A, and this one is just the integer that iterates over the indices of A, and so. So you compile it, that makes the class file, and then you run it using the Java interpreter today. So, so there you go. This is just basically review stuff. So now for a little fun. So Java is compiled. So it's a language where you take the source code and you have to compile it, and that makes another thing. So what are the, let's say, somebody who knows, what are the disadvantages of a language that you have to compile? Yeah.
Unlike Python for testing, you can't just say like A equals this within the terminal and test that.
Yeah. So one thing is you generally, for compiled languages, don't have a real interactive mode, because every time you change the code, the whole thing has to be recompiled, and then there's no interactive mode. So that's a disadvantage. And what about an advantage of compiled code? Usually executes faster. Okay. So the other option, if you don't compile, is you can interpret, which is what Python does. It goes through and it reads the code, and as it's reading it, it executes each line that it reads. So the advantage of interpreted code is usually that it's very dynamic, very flexible. You can have things like pause the code, or have an interactive mode where a piece of code executes and then you type another piece of code and that executes, and so on. So you get this nice dynamism, but it's a little bit slower because when it runs, it actually has to read it, interpret it, and go through all that process. Now, Java is an interesting case of a programming language that it's not really dynamic because you have to compile it. And, well, you also have to interpret it. So it's simultaneously difficult to work with and non-interactive, and it's slow. So it really gets the best of all worlds for whatever reason. But it's portable, so it runs on a lot of different systems. Okay, so there's our review. So for those in the know, we use lists in Python, and in Java we have arrays. What's the big difference between those two things? Yeah. Yeah. So the size of an array is a fixed thing. It's fixed at the time you define the array. So for example, here we defined an array that had 3 elements. That array will always have 3 elements in it. There's no way we can change that. We could change this variable a so that it points to a different array, but that initial array with 3 elements is going to live off in memory somewhere. We can't make it bigger. We can't make it smaller. There's another way to declare arrays, where we do say something like, you declare an integer array, let's call it IA, and say that's a new int 10, or let's say n even. So that's an array whose size is a variable, but still, at the time we create it, that's the size of the array, and that's it. There's no changing it. The closest we could come to changing the size of this array is to create a new one, copy everything over that we want from the old array into the new one, and then throw away the old one and keep the new one. That's the best we could, the closest we could do to changing the size. Unlike Python's lists, in which we have this append operation, you can stick things on at the end of a list. And in Python, we even had this delete operation where you can say delete an index, and suddenly that index disappears and the list gets shorter to fill it in. It turns out that lists are really useful. So arrays are good, and they're nice and fast and simple, but there are times when you want something that can get bigger. For example, you're reading a file, and you don't know how many lines are in the file before you get to the end. Or maybe it's not a file. Maybe it's actually something that somebody is, you're writing a web server, and what happens is somebody's uploading something to you. Then you really have no way of knowing how much they're going to send you, how many lines they're going to send you, until you read the last one and they close the connection on you. And so, so there are times you want these things to be able to grow. And, well, Java actually has lists for that. But they're a little more complicated. So the first thing I want to point us to is the Java list interface. So if you just Google Java list, one of the first hits that comes up is from the Oracle documentation. So the Oracle documentation for Java is the sort of standard. It's the place you should trust for documentation about Java stuff. This is a slightly older version of the API 6, but doesn't matter. It's this part of it hasn't changed. And it says there's this thing in Java called a list. And this list lives in the java.util package. So just like in Python, some things are built in, they're always there in the language. In Java, those are things that are in the java.lang package. So I'll just make a note of that. Java.lang is included by default. But this package here is not java.lang, it's java.util. So if we want things out of it, we have to include them. Or we have to import them. So we want to import java.util.list. So that means we can use a list. Now, this thing is an interface. So it's not a class. So we've been defining things. You know, we defined a class here, and the objects that we typically have are instances of some class. This is an interface. So any Java programmers know what the difference is between an interface and a class? Yeah.
Interface is like a set of methods that class has to implement.
Yeah. So an interface basically is just a list of operations that that something supports. So for example, you can think of a list as supporting the operations of adding something to the end of the list, or getting a value from somewhere in some index in the list, or setting a value for some index in the list. But it doesn't tell you how it does it. It just tells you that it does these things. And so the this list thing is just an interface. So the interfaces and classes will come up frequently. The differences between those things will come up frequently as you program more and more in Java. But they're it's a really important distinction, and I believe it's important that you learn these basically as soon as possible, because it takes a while to get to fully understand the distinction and when you should be using one versus the other. But the short version of this is I can't actually make a list just from the interface. The list interface just tells me what lists do, doesn't tell me how they do it. If I actually want a list, I have to look for a class that implements the list interface. And here's one. It's the ArrayList class. And if you look at it, okay, there's some documentation associated with every class. It tells you where it is in the whole inheritance hierarchy. It's a subclass of abstract list, which is a subclass of abstract collection, which is a subclass of object. That's not really so important to us. What's important to us here is that it implements the list interface. So we can use these things like a list. Now, both lists and array lists, they're written in this funny way with these square braces, or not these square braces, but this less than and greater than symbol. So that thing is called a diamond operator, because when there's nothing in between, it looks kind of like a diamond, maybe. I don't know. And it tells us that, well, this is a class that's not fully specified as is. You have to also tell it something else. So I can't just say make an array list. In the same way that I can't just say make me an array, I have to specify what's going to go in that list. So what has to go in here is the name of some class of things that you want to store. So let's put all that together into a line of code that makes one of these things. And again, array list is something you have to import. So I want to say, let's say we'll make a list, and let's say it's going to be a list of strings. We'll call it L. So this is a declaration of a variable called L, and what is L? Well, it's a list of strings. And then I'll set it to a new array list of strings. All right. So over here, what I care about is that this thing is a list, and on the right-hand side, well, I have to tell it something that can be a list. An array list is an object that implements the list interface, so it can act like a list. All right. So let's try and, well, see what we can do with this thing. So lists, you can add things to them. So let's say first string. Let's add second string, and let's add third string. And then we can print it. Okay, so when we print it, we actually see it nicely, a nice representation of it. It contains first string, second string, and third string. So you can add things. So adding is basically, this is equivalent to Python's list.append, right? Python lists have an append method that puts something at the end of the list, and that seems to be what this does, right? Because we added them in this order, and so each one got stuck at the end, so they came out in that order. But there's another variant of add in which you can specify the index you want to add it to. So you don't just put it at the end, but put it in some particular location. So for example, I can say I want to add something at position 0, and we'll call it the 0th string. So let's do that and see what it looks like. So there, that last string that I added, I said that I wanted it at position 0, and indeed it did go at position 0. And it doesn't overwrite what was at position 0, it just pushes everything out of the way to make room for it. So it actually grows the list. And of course you can remove things. So for example, if I want to remove something from this list, let's say I'll remove the element at position 1, which is the string, first string. And indeed, once we remove the element at position 1, it's gone. It removes it, doesn't just set it to some empty string value or anything. It really gets rid of it, and the remaining elements get pulled back in the list. So there's a new element at position 1 now. So it changes the indices of everything that comes after 1. So this is actually equivalent to Python's, we didn't use it much, so you can delete an element of a list. I think there's an insert or something in Python that's like this, but whatever. We never use it much, and I'll warn you that although you can add or remove at specific locations in a list, it's often not a good idea. In particular, if you have a big list and you're constantly adding and removing near the front of the list, so near position 0, that ends up being slow. And the reason is just that behind the scenes, lists are just arrays that sometimes get bigger and smaller. And so when you do something like this, where let's say from here to here, what I did was I inserted something at position 0. Well, really what happens is everything at positions 0, 1, 2, and 3 in this case has to get copied and moved over by one position inside an array, and that leaves room for this thing. And similarly, when I delete something, everything that comes after it has to be pulled back one position in the array. So that takes as long as, the time that takes is related to the number of things that come after it. And so the only place where it's really fast to do that kind of stuff is near the end of the list, where you wouldn't have to move very many things. And right at the very end, you don't have to move anything, right? If you add to the end of a list, there's nothing that needs to be displaced. If you remove the last item, there's nothing that needs to be shifted back. So these lists are like arrays, but a couple of things are different. So if I want to iterate over it, I can use this same mechanism here that I did before. So I can use it's called a for each loop, which will assign each value in L one at a time to S. Or I can use this 3-part for loop. The only major difference well, there's two major differences. So this is basically the same as before, but here, so notice that we say L.size. So lists have a method in them called size, which tells you the number of elements that they contain. For arrays, we didn't do that. We just used a.length. So arrays have a property called the length, which tells you how many elements that are in the array. So that's one difference. And then the other thing is lists, we don't get to use this notation to index them. So to retrieve an element, we actually call a method called get. So we get the ith element. If we try and do something like this, then what we get is a fairly well-worded error. It says an array was required, but you gave me a list, and that's because you're trying to use the array indexing operator here. So this is like L at I, but you just don't get to do that. Okay. So those are the main things we do with lists. Let's try and do something really simple. Let's write a version of so here I want to write a Java version of Python's range n method. Okay. So I want to write a function that takes an integer argument n and returns a list that contains 0, 1, 2, 3, 4, 5 up to n minus 1. Okay. So first thing I need to do is just write the prototype or the definition of the function before even filling in the code. So I want it to be public because, sure, it seems like a useful function. Everybody should be allowed to use it. I want it to be static because there's not really any object tied to this thing. It's not a function that operates on an object. It's just something you call and you get back a result. So it's just really a function. But then the next thing I need to specify here is a return type. So what would the return type be for the range function? So I want it to be a list, so an integer list. And what does that look like? So why integer? When we looked at Java's types, we saw that there were int, float, double, short, long, fat, skinny. No, there's no fat and skinny, but there is short, long, no tall either. So there's these types, and the one that we seem to want is int. So why don't we use that? Yep. Yep. So it turns out that there are some types that are more equal than others in Java, and anytime you want to use something like a list, and we'll see some other types of container or collection objects, they can't hold anything. The only thing that they can hold are different kinds of objects. And so they can't hold ints, they can't hold floats, they can't hold doubles, shorts, or longs. These are really these primitive types that have, int is 32 bits, float is 32 bits, a long is 64 bits, short is 16 bits, and so on. All we can put inside of lists are objects, and so every primitive type comes with an associated class that basically represents things. It's an object of that type. So for int, there's integer. For float, there's float with a capital F. For double, there's double with a capital D. I believe there's a short, and I know there's a long. So in our case, we want a list of integers. Okay. So I guess at this point, just a poll, something someone told me about the tutorials is it seemed like many of you were really happy to get back to Java programming. Is that true? No? So people with Java programming experience, was it nice to go back to Java?
It was until I realized how much extra syntax there was.
Yeah, so suddenly it feels clumsy all of a sudden, and there's a lot of weird rules and things all of a sudden, like can't put ints inside a list, and you need public static void main string args, and so it's a more complicated language, which is probably funny in some sense, because when you started programming in Python, that probably felt like the thing that was difficult. Now that you're going back to Java, you're realizing, well, actually, somehow Python was a nice language. But anyway, let's finish this thing. So I want to make this list now of integers that contain 0 through n minus 1. What's the first thing I should do? Should create a list so I can fill it up. So I want a list of integers, which should be a new array list of integers. So that makes my list. Now what? For loop. So a for loop like this. Oh, let's call this thing L. For loop like this. No, that's useless. L is empty, and so if we iterate over the elements of L, nothing happens. So we want one of these three-part for loops that starts at 0, it goes up to n minus 1, and it increases by 1 at each step. And every time this loop executes, what do we want to do? L.add I. And then finally, we've made this list L, we've filled it up with these integers, we can return it. And now we can test this thing. My main reason is just that this text is about as small as I would want it to be. Now, if you've used Eclipse, you've seen how much it fills up. There's a lot of stuff there. So basically, if we were using Eclipse, our programming window would be about this big if I was using fonts that size in Eclipse. So not great. IDEs are fine for Java, and I recommend using them. I don't know if is there anywhere that you got information about which IDEs to use and not to use? Okay, so don't use JCreator.
Why not?
Because it's awful. It's awful. It has all of it's like Java in the sense that it has all of the drawbacks of an IDE and none of the advantages. There's a lot of very powerful things that IDEs can do for you, and JCreator can't do those things. And then there's some things you have to pay for with that, which is not knowing where your files are and all that stuff. And so JCreator has all the bad parts and none of the really good parts. If you use something like Eclipse or even NetBeans, they have a lot of really powerful refactoring tools that help you fix problems like, oh, I chose a name for a variable a long time ago. Now I'm using that variable all throughout my code, and I realize that that's a really bad name for that variable. It's not a good name. I would like to change it. Usually what happens is you say, it's too much work to change it. It's just going to have to stay the way it is. If you have a good IDE, you can just do a renaming refactor, which will change the name of that variable and find everywhere it occurs in the code and fix that properly too. Just using find and replace doesn't usually work because that variable could be a substring of another thing, and that can lead to a mess. But it can do even more powerful things than that. Like, you thought that this class should be a subclass of one thing when really it should be a subclass of another, or you put a method in this class, maybe it should be in the parent class. It can do all of those good things. So Eclipse or NetBeans, apparently NetBeans is the better Java IDE. I've never used it, but people who are in the know tell me that it's actually a better Java IDE. But Eclipse is a better IDE in that it supports more programming languages than Java. So it can be your IDE for C++ or Python or any of the things you want. Okay. So let's test our range function. So there it works. It creates range 20, gives us a list of 0 through 19. Now here's your programming challenge for the day. It's not a difficult one. Rewrite this range function so that it doesn't introduce an extra variable. So here we use this variable I to do our counting for us. Rewrite this so that you don't need that extra variable. Yep.
Or open bracket
this. Yes. So we could use a while loop, and then we know we're not done as long as the length of L is smaller than n, right? We're trying to make an array with n elements, and we know we're not done until the length is equal to n. So that does that. And well, if its length is not equal to n, what should we do? So the first time through this loop, what would we want to do? We'd want to add a 0, right? Now the first time through this loop, what's another word for 0? What's that? I think you know the answer. It's L.size. So first time through this loop, L is empty, so L.size is 0. Second time through this loop, L has one element, so L.size is 1. So this just basically hides our counter, or means we don't need this counter I because the list is already keeping track of it for us. It's the size of the list. So there's your slightly more, I won't say more efficient, but more difficult to understand version.
But is it actually more efficient in any way because it doesn't use the variable?
It's more efficient in the sense that there's now one stack frame which has one less int inside of it. So it saves 4 bytes of memory on your 8 gigabyte computer. So out of the 8 billion bytes on your computer, 4 of them less are now used by this. On the other hand, it's probably less efficient because now instead of accessing a local variable inside of the current stack frame, it has to call a function to figure out what the size of L is. So it's probably slower and uses marginally less memory. But neither of those things will make much difference, neither the memory usage or the speed in this case. It's really just a puzzle. And so the winner, if you had to write one of these things and decide which one you wanted to do, I think this would be the winner because when someone reads it, it's easier for them to understand what it's doing than this. This takes a little bit more reasoning to work through. So unless there's a real benefit to doing something in a trickier way, you should do it the simpler way. Here there's no benefit. Okay, good. Well, and I guess then the other thing that I could show you is not only can you get elements in a list, but you can set them. And so you can say set the ith element to some value. What's L got in it now? L is a list of strings, so we could set it to, for example, null. And this is like saying L at position I equals null. But we can't index lists using this array notation. Instead, we use the set method. What's that?
That's just deleted.
And I don't want to print it. Well, let's see what it does. Don't need that. So the question is, isn't that just going to delete L? And the answer is no. It's going to turn L into a list that has still has three values, but each value is null. So no, it doesn't delete it. If I wanted to delete it, I would do something like remove some value. Okay. And in fact, here's a puzzler for you, maybe. So if I did want to empty all the elements out of L, you might say, well, what I'll do is I'll go through this list and I know how to delete the ith element, I just remove it. So is that going to work? Yeah.
I don't think so because I keep skipping.
Yep, so it'll work for a little while. So initially this will go through this thing and remove the 0th element. And then it's going to increase the value of I to 1, and then it's going to remove the 1th element. So already there's a new 0th element back there which was not removed. And then it's going to remove the 1th, which increased the value of I to 2. So now there's 2 elements which weren't removed. And eventually it's going to, it's not going to empty the list. We can try it and see what happens. And you may meet your, so it leaves us with a list that still has 1 element in it. And that's because I goes off the end of the list, but there's still some stuff that got left behind I. In this case, the list was only 3 elements. If we had a big list, we'd still get about half of them left over. So a much better way to do it would be to say, while L dot size is bigger than 0, L dot remove L dot size minus 1. So this works. So we remove the last element and not the 0th element, because I told you that's a bad idea to remove things from the beginning of a list, so you would remove the last. But even better is just to do L dot clear. So I'll just put some comments here. This would make the list empty. This would make the list empty. This tries to make the list empty, but it's wrong. Of course, by this point, the list has been emptied twice, so it's going to look okay. Okay, and one other thing I want to show you is, at least before we leave lists, is a method called sublists. So let's say list of integers, we'll call it the integer list IL. And I'll make another list of integers called SL, which is a sublist of range 2. And let's take the sublist, which starts at position 10 and goes up to, but does not include position 15. So this is the same thing in Python. We would write this as SL is equal to IL from 10 to 15. Okay, can't find symbol, range 2. Why did I say range 2? Okay, so this is the original list, and this is the sublist that contains the range 10 to 15. So this is like an array slice in Python. Now, is anybody really a pro at Java here? Anybody tell me why this is, what's different about this compared to Python? let's do something. Let's say in SL, we'll set element 1 to be, the element at position 1 to be 1000. So if this is SL, and we set the element at position 1 to be 1000, what do you think is going to happen? Nothing? It won't get changed to 1000? Well, let's see. I would think that this 11 here would turn into 1000. So who thinks that's going to happen? Who thinks that's not going to happen? Yeah, okay. And then the rest of you, I'm not sure what you think, but doesn't matter. So indeed, it does what you expect. You set the first element to 1000. That's not unexpected. So why am I bothering to show you this? Yep. Yes. Let's go back and look at IL now. So not only does it change SL, the sublist, at position 1, it actually also changes the original list at position, in this case it's position 11. So why is that happening? Well, that's happening because this sublist method is actually a really efficient way of extracting a sublist, because all it does, there may still be a picture of this, all it does is something like this. If I have a list, in this case the names have changed a little, this is my list IL, so it's off and there's some array somewhere in memory that stores all the elements in IL. They're really numbered 0 through 19. Don't ignore the fact that they're reversed here. When I create a sublist, all I get is a pointer to the same array with a couple of indices that say, well, actually start looking here and only look at 5 elements, which is fine. So that means if I look at SL, it looks to me like a list that has 5 elements, and those elements start here and count up. And that illusion works perfectly unless I change something in that list, which is what I did. I took element at position 1 and set it to 1000. That causes an issue because both SL and IL share this array. So when I change an item in one of them, it's actually changing them in both of them. So whether that's a good thing or a bad thing depends on your point of view. There is one really nice thing about it, which is that this operation takes constant time. So I can extract a sublist that has 1,000,000 elements, and that's no longer than extracting a sublist that has 5 elements, because it's just getting a pointer and then keeping a couple of indices. And so that actually means that there's something that we tried to do when we were working in Python that turned out not to be efficient, which would be efficient in Java, which is when we implemented binary search, we tried recursing on the first half of the array or recursing on the second half of the array. That turned out to be slow because if you just do array slicing, that means you're copying the whole first half or copying the whole second half, which was no better than looking at all the elements in it. Whereas you could, so we had to play around that and make a second function which took extra arguments and deal with those. Whereas in Java, you really could write a recursive implementation, and at each step you pass it in a sublist of the current list. Yep.
What if you call two-array method on sublist? Is that going to create a copy or?
To array? I don't know. But if you really wanted, so I don't know what happens. I think toArray actually gives you a whole fresh array regardless. But if you wanted a copy, you could use, I believe there's a method called collections.copy. So you would do something like, you know, if you really wanted a different sublist entirely, you would do something like collections.copy. this sublist, which would give you a fresh, brand new sublist. Change it all you want. It's not going to affect the original one. So you really do have the choice, but it's extra work if you want the copy. Okay, a couple of other things. There is a class in there called collections, which has a bunch of useful methods. We'll just demonstrate a couple of them. One of the methods in there is collections.shuffle. So I can take a list, for example, IL, and shuffle it. And that's just like what we do in Python with random.shuffle. So it took this nicely sorted list, or almost sorted list, and just randomly permuted it. If I want to make a sorted list, I can use collections.sort, which will sort it. So this line of code here is like random.shuffle that list, and this code is like, in Python, this would be calling the sort function on the list. So there's the original list, shuffled, and then sorted back into sorted order. So all useful things that you frequently end up doing. Okay, so now I think we know about lists and we know about some of these extra routines. Yeah.
Is there any function for like summing a list or something?
Not really. So, I mean, the thing about Java is there's a lot of different libraries for it, but I don't think there's any. There's probably a library somewhere that will sum the elements of a list, but not built into the standard Java API. For that, you use a for loop. Yep. Let's just check. Somewhere we made an array of something. No, I think you use arrays.sort. So if you had an array, you would do something like this. I'm pretty sure. So there's another class called arrays, which is like collections, but it'll do that. Okay, so we know all the primitive data types. We know about arrays, which Python doesn't really have. And we know about lists, which is like Python lists. What are other things in Python that we haven't seen the equivalents in Java yet? Sets and dicts. So in Java, there are also sets. And just like lists, they come in two parts. There's the set interface, and then there are some classes that implement the set interface. So the set interface is just called a set. It's in the java.util package. And then there's the class, which is the one you're most likely to use is a hash set. So there's nothing too much to say about them. So we've seen how you do lists, and sets are similar. So we could say, for example, set of integers. Let's call it S, and say is a new hash set of integers. So you can add things to a set. Oh, why did I want to add S? I want to add I. So this creates this new set of integers that contains 20 numbers, and well, sets are unordered, distinct elements. So if you look at this thing, you'll see that even though I put the elements in sorted order, they're not quite in sorted order. So these get a little bit messed up towards the end. Sets don't promise that they're going to preserve order, so that this one doesn't. You can remove things from sets. Looks like this, let's say. So this removes all the even elements, starting at 0 and counting up to 20 by 2s. And the other fast operation for sets is asking if they contain something. So let's ask if this set contains the number 10. And let's ask if it contains the number 11. So S dot contains 10 returns false, because indeed there's no 10 in that set. S dot contains 11 returns true. All right. And those are basically the three things you want to do with sets: add, remove, and check if they contain something. That's really fast. And then the other thing that you mentioned were dictionaries, or dicts. So those actually have a different name in Java. They're called maps. And they come in two parts. There's the map interface, and then there's some implementations of maps. And the one that you'll generally want to use is the hash map. Now, declaring these things is a little bit different, because what's the difference between a dictionary and a set in Python? So a set stores a bunch of elements. A dictionary stores a bunch of key value pairs. And in Java, you have to be very precise about the type of everything that you're talking about, which means you have to specify both what the key is and what kind of keys you want and what kind of values you want. So when you create a map, you might have something like a map that takes strings and maps them onto integers. And then you add things to it. So let's call this map M. So at Pat, I'll put the integer 42. At Jeff, I'll put the integer 22. And we can look at what that map looks like, and what happens if we try and get Pat. Then you get this crazy error here, difficult to read, but does anybody see the problem? Yeah. Yeah. So I tried to put a string in, and I should have been putting an integer there. So method, blah, 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 put cannot be applied to given types. Jeff22 requires a string and an integer, and I gave it a string and a string, so it's unhappy about that. But there you go. So it maps these strings onto these integers. And so now, so maps, you can get values, as we've seen, and you can put values, and you can remove values too. So I can say m.remove pat. That just takes the whole pair out of this thing entirely. So now the key pat is just gone after I do that. So now it's time for your bonus for coming to class. So pay attention.
Is this stuff going to be posted up there?
Nope. In fact, I will